Okay, good afternoon. Welcome to this second series of inaugural lectures. Last week we had the first two presentations of new staff members in the department, Earth and Environmental Sciences. And I'm very happy to introduce to you two other new colleagues that started in the last few months. And Arie Stoffelen will kick off today. So I'm very pleased to introduce you to Arie. He's a true geographer. Unless, in fact, the other four new colleagues that we present to you last week and today. He's also Dutch, but he studied in Belgium from the start. So he studied geography here in Leuven, both bachelor and master program. Also obtained his PhD here in geography under the supervision of mainly Dominique van Este on tourism and regional development in European borderlands. And then he moved to Groningen to become an assistant professor, where he also coordinated the master program in cultural geography. And that already gives an indication of his broad expertise, in fact, combining cultural geography, heritage, tourism studies, and especially a strong interest in border regions. And that's also where he will continue his research. Now, he will also be contributing to the bachelor and master programs in geography. He will give a bachelor course on economic geography and also contribute to the master program. And we're definitely looking forward to your contribution there. And also to the fact that you will be able to link up with different groups, not only within the department, but especially also with other research groups in the humanities. So Arie will be very important in strengthening, let's say, our interactions with, for example, heritage studies, with history, etc. So Arie, I will give you the floor to explain in, let's say, half an hour what your research will be about. And welcome back in Leuven.
See if it works. This one doesn't. Right. Good afternoon, everyone. Welcome also on my behalf, and it's a great honor and my pleasure to give my inaugural lecture today to mark my position here as professor in geography, mostly specialized officially in the flows of people and money. The flows of people and money is, of course, quite a broad theme, open to various research approaches, open to various research focuses. So with this lecture today, which is entitled The Geopolitics of Cross-Border Immobilities, I hope to lift the veil a little bit as to how I understand flows of people and money, my own edition in a globalizing society, and how I currently study this at KU Leuven and how I will put this into a research agenda for the future as well. I can obviously start with a bit of a theoretical reflection on what flows of people and money are about in the globalizing environment. But I'll start with an anecdote instead. An anecdote of a very practical experience that I had roughly 8 years ago. And roughly 8 years ago, with that I mean summer of 2014. In the summer of 2014, I was in the borderlands between Germany and the Czech Republic, as Professor Verstraete just said, to study tourism and its cross-border regional development effects. But it was basically looking into how tourism contributes to breaking down administrative barriers, economic barriers, but also social-cultural barriers, and what the main obstacles and hindrances are to make use of tourism and tourism's potential to build bridges between different countries. At a certain moment in time, I was in exactly this place. It was a railway station in a very small German town called Marktredwitz in the federal state of Bavaria in Germany. And I was planning to board a very small local train, exactly the one that you see on the left of the picture. It was a small train that would bring me to a very pretty Czech town called Cheb, which is just across the border in the Czech Republic. And this is a very small local line, takes only 30 to 40 minutes to get there. So once I boarded this train, I was looking forward to actually going to the Czech Republic. Everything was going very well until after roughly 20 minutes, we basically still had 2 stops before we entered the Czech Republic. 2 people boarded the train carriage, and they were actually quite intimidating looking people. Right, one of them was a very tall guy, bald head, bulging muscles, and he wore a black Muay Thai kickboxing t-shirt. These turned out to be Czech border police officers. Right? What did they do? They wanted to check if no rough elements would enter into the Czech Republic. So what did they do? They collected all passports of the train passengers, everyone included, so including me, and they checked whether your name resulted in any red flags in the Czech security database. How did they do this? They didn't just check it, where you were sitting. No, they collected all passports, so a big stack of them, and took them all the way to the end of the train carriage, and then called in every individual name. I could just about see them just at the end of the train. Right? Of course, this is quite an unpleasant experience, right? First of all, the appearance of these people. Second of all, you have to hand over your personal documents to these people, and they walk away with it, which isn't a fun experience at all. And thirdly, you have no idea what will happen next, right? What red flags in the Czech security database actually mean. So after a few anxious moments, luckily I got my passport returned, but in fact there was one person taken off the train. Now, to me, this was quite a confusing experience because I was there to study something completely different, right? How we could make sure that borders are lowered as much as possible, right? How tourism, so cross-border mobility, could be facilitated to such a degree that we can actually work towards a borderless world, right? A borderless world in terms of identity, a borderless world also in terms of economic exchange, of broader, not just economic growth, but definitely also just economic development for everyone. And in fact, if you look at the development plans in that area, it's all about cross-border collaboration. Right? You get maps such as these, not Germany on one side, Czech Republic on the other side, but you see a cross-border area. You get the stories that the location in the heart of Europe is such a massive advantage for this region. But if you look at this map, there's no hierarchy between international borders and the domestic borders between German federal states. But in red, by the way, is the location of the 2 railway or the 2 towns in the railway connection. Cross-border commuting is actively facilitated, actively supported to break down these border-related administrative barriers and barriers regarding the labor market. You got an Agronet ticket, which is a ticket where you just have to pay one price and you can use public transport in the cross-border area for unlimited amount of times during the day. Also, tourism is actively pushed to break down these border-related barriers. And you got very high-profile tourism products, such as the Iron Curtain Trail, which is hiking and cycling all along the previous Iron Curtain. And they use slogans such as experiencing the history of Europe's division. Right, basically, the idea is if you as a tourist experience this heritage border landscape, you learn from our mistakes in the past so that we will not make the same mistakes in the future. Basically, bottom line is we need to work towards one shared European space, right? A cohesive European space in terms of economics, but definitely also in terms of society. Parallel project is the European Green Belt, uses similar slogans: borders separate, natures unite, nature unites, and from dead zone to lifeline. Also across the border, plenty of tourism projects actively supported by Europe, plenty of European co-financing being put into tourism projects. These are just hiking and cycling trails, which is just the tip of the iceberg in terms of cross-border tourism investments there. All investments made to make sure that we create this shared European space. And to me, this was, of course, quite a confusing experience that I had right there at this border, in this train between Marktredwitz and Gap. Right, the contradiction between both really struck me. So, for the time being, I just, left that aside and I focused really on what's the role of tourism in this whole process, breaking down these barriers and so on. And this is something that I studied back then, that I'm studying still nowadays. And this whole focus on the role of tourism as a societal development tool is still something that requires quite a lot of research, and arguably even more research in the future. But if you just purely look at number of tourist arrivals, this was just pre-COVID, of course, and you see that since 1950 we've seen a massive increase in international tourist arrivals. Right, So tourism impacts, social impacts, environmental impacts, economic impacts of tourism are massive. So understanding how we can optimize these, not for the tourism industry, but definitely for society, is something that's fundamental. Right, and there's no indications that COVID has led to a systemic change in this respect. Right, it's very realistic that we'll just go back to business as usual once everything is possible again, with border openings and so on. So this kind of research line that I developed back then, specifically focused on borders, but in general, is still something that I do today. Also now at KU Leuven, this is one of the flows of people and money that I'm studying. And in fact, in just a couple of months, I'll get this handbook of tourism impacts out, which I edited together with a colleague and a good friend, Dimitri Ioannidis. But I hadn't forgotten this experience, which basically lasts 5 to 10 minutes, right? This experience on the train between Marktredwitz and Gap. And I had some problems with purely focusing on this one research line, dealing with tourism impact. Because this is all nice and well, and it's extremely relevant, and we should continue doing that. But we can't really explain what's going on, or the experiences that I had back then, by purely focusing on tourism. Because clearly something else is going on as well. Right? Something else where tourism is just one of the elements. So since 2014, since developing this research line, I've been thinking we should do something in addition. We should actually take a step back. But we should still study tourism as a lens to understand our society. But if we want to do so, we need to challenge tourism itself as well. Right? We need to understand tourism more than as just a societal phenomenon, but as just one of the societal phenomena. And how can we do this? But as I said, taking a step back and understanding tourism as a form of border crossings or as a form of mobility, but just one of the forms of mobility. Because if we do so, we can understand tourism as a symbolic way to work towards a shared European space, right? To work towards a unified economic space at the same time. But we have different forms of border crossings as well, of course. Right? Take, for example, migration. And if you understand migration as a form of border crossings, similar kind of mindset, the perspective shifts fundamentally. Right? All of a sudden it becomes a domain that's framed in a whole discourse of regulation, control, and prosecution. And in fact, these two things are not separate. Right? They occur in exactly the same borderlands. They just refer to different people and different forms of mobility. And by purely focusing on tourism alone, you don't see these kind of things, right? You need this kind of meta level perspective. You need to take a step back and understand, what's going on here, right? And it only happens if you understand mobility as a form of border crossings. It may come as a surprise, but nowadays there are more border walls in the world than there were in 1989, at the end of the Cold War. Right, so international trade has incredibly increased. International tourist arrivals have massively grown, as you just seen on the graph. Migrant mobilities have increased over time as well, but we also see that there are more border walls nowadays. Right? Border walls that are increasingly digitized, increasingly technological, and that are more pervasive in society, right? They're present everywhere, not just at the borderlands themselves, but they're present in our daily lives and everyday, also digital infrastructure. Now, an important nuance that needs to be made about this role of borders is that borders function quite differently nowadays than in 1989. In 1989, the basic idea of especially a border wall was to keep the sphere of influence of enemy territory as little as possible. But you wanted to make sure that the territory on the other side of your border wall didn't extend its sphere of influence to your territory. Right? So you had nation state versus nation state or world group, so the West versus the East in Europe. Nowadays, if you look at borders, it's much less territorially oriented. It's much more oriented towards the individual. It's about making sure that you grant access to the people who have, well, supposedly economic value and sociocultural value to your territory. But you want to keep the people who supposedly do not have these kind of values, you want to keep them out. Right, so it's much more oriented towards people, towards individuals, and the ability of individuals to be mobile. Now, of course, this leads to selectivity, because on the basis of which criteria will you grant access to some, and will you keep others out, of course. So this is a quite selective policy, which results in mobility inequality, and you can also argue mobility injustices. If you want to study this kind of changing role of borders in our globalizing society, where to do this? Europe is a very good starting point. Because Europe has a very particular border policy, a border policy that's sometimes summarized as Fortress Europe. Fortress Europe basically means that Europe has open internal boundaries, or at least almost open internal boundaries, but they only do that because they have very hard external boundaries. Right? So what Europe's policy is to have extremely hard selectivity checks at the external borders, but once you're in, you're in. Now, this kind of border policy is, of course, very much, as I said, digitized, technological, but it's also very much discursive. Right? It's symbolic. It's embedded in maps that are created. It's embedded in the symbolism by a border police officer wearing a black Muay Thai kickboxing t-shirt. It's about all the symbols that you basically send out. You are welcome here or you're not welcome here. Now, a lot of research on this topic is done at the University of Nijmegen in the Netherlands, among others Henk van Houten. And he's shown in a very recent paper some very interesting things about this. Because the map that I reproduced here is a map made by Frontex. Frontex is Europe's border patrol agency. It's basically the organization, the para-state organization that's responsible for making sure that Fortress Europe happens in reality. So what do you see on the map? You see, first of all, that Europe takes a relatively small, has a relatively small surface compared to the total surface of the map. Right, so it's pushed in the top left corner, making it relatively vulnerable compared to the territory surrounding it. Second of all, you see that Europe is presented as being homogeneous, right? No internal borders to be seen, in contrast to all the areas around it. Third, it's presented as being a friendly space, in the sense that it's a very soft color that's being used, a light shade of blue. If you compare that, fourthly, to the migration flows, that's what the big arrows are, and you see that these migration flows are strongly overrepresented here. They're basically the size of the European continent, and they're depicted in big, bold red colors, classically a color that you associate with violence and danger. Right, so what Frontex basically does with this map is that it justifies a certain border policy of Europe, which is extremely selective, creates very strong mobility inequalities, and you could also say very strong mobility injustices. And the fact that managing people's access to territories has become a geopolitical tool becomes very clear with this example. This is an example that made the headline news just before Russia invaded Ukraine. And actually, in fact, there was yesterday another newspaper article about this on the VRT website. Right, this is refugees basically trying to enter European territory in Belarus. Right, what happened? Belarus had elections, clearly fraudulent. People went to the streets. Lukashenko didn't like that, disabled down these protests quite violently, and Europe imposed sanctions on Belarus. What was Belarus's response to this situation? They chartered airplanes flying to Lebanon, among others, to bring asylum seekers, refugees from the war in Syria, to Belarus, saying, here's your ticket to Europe. The Polish border is just over there. What did Poland do? Erected even more border walls than there were already, more armed border police, and this resulted in quite a humanitarian catastrophe, actually. People, including young families, spending a winter in the middle of the forest in Eastern Europe. Right. The contrast with refugees now from Ukraine is, of course, also at the Polish border, is, of course, enormous. Right. So what you see here is actually that people's mobility, access to territories, is being used as a strategic tool, right, as a geopolitical tool. The conflict was between Belarus, so a nation state, and a supranational entity, the European Union. Now, how is this geopolitical dispute fought out? Over the heads of individuals, right? People who are supposed, well, do not have the rights to enter Europe according to Europe's border policy. If you contrast that to this map, then the contrast becomes extremely stark. Right, this is a map by the Association of European Border Regions and outlines all structural, systematic cross-border collaborative platforms that are in place in Europe. Right, so these are not just individual projects, such as an Iron Curtain Trail. These are overarching umbrella organizations or collaborative platforms in which all these sub-projects are being managed. And so you see, it's enormous, right? So you have, on the one hand, enormous investments in breaking down barriers within Europe. You've got enormous investments in building border walls at the same time. And in fact, we've seen this similar mobility inequalities in the COVID pandemic, or just after the first wave of the COVID pandemic. Because what was the main reason why in late spring, early summer of 2020, borders opened again within Europe? It wasn't because families were separated or so, it was because the economies of countries such as Spain and Italy, very dependent on tourism, absolutely needed the money coming in. But they were hit very hard by the first COVID pandemic. So we should actually open these borders to make sure that they got money again. And this resulted in newspaper articles to hear from The Guardian, the Balearic Islands prepared to welcome 11,000 German tourists. And there was a safe corridor scheme to reactivate Spain's travel sector. Another newspaper article with the title, "We're Desperate to Dance. Britons in Mallorca express relief over quarantine easing." In exactly the same summer, just a couple of months later, you saw plenty of newspaper articles on migrants drowning in the Mediterranean Sea, and just about the same time also, especially towards the Canary Islands. Right, so the contrast in titles couldn't be starker, right? So the lack of humanity can't go on. Canary Islands struggle with the huge rise in migration. Now, if you're advocate of the devil, you could say yes, but you're comparing two different things. Right? People moving within Europe versus people from the outside of Europe trying to enter Europe. First of all, I would say there's nothing natural about having such an extremely harsh external border in Europe. This is an active policy. Right? This is an active construct. There's not written in the stars that you need to be as selective as it is. And especially on the basis of which criteria is very much open to debate. But this is extremely harshly done. And second of all, I would also argue that making a hard distinction between external and internal borders is a bit of simplification. Because take this example. This is the example of the border between Hungary and Serbia. Right, the border between Hungary and Serbia was militarized extremely heavily after 2015. 2015 was the year of the so-called wave of migrants that were crossing the European continent, related, of course, to the war in Syria. Now, if you make that picture in black and white, you'd also believe that it was the 1970s Iron Curtain, right? It's almost the same. Very heavily fortified border, barbed wire fences, patrol roads, and a border police at the back. Now, if you plot that location on the map of the Association of European Border Regions, you see that this is one of the areas in Europe where most cross-border collaborative platforms exist. Right, so you see massive amount of money being invested in breaking down borders, massive amount of money being invested in building up exactly that same border. Right, the difference is just different mobility forms, different individuals. Also within Schengen, border between France and Belgium, if you go to Calais by car, you're still diverted off the highway to a parking lot where French border police is present in large numbers. Again, this is this symbolic, this discursive border creation, what I talked about, right? Very similar to the intimidating border police officer that I encountered on the German-Czech border, just to show to you that we're here to watch you. And in fact, also here, plenty of cross-border collaborative arrangements. One of them nearby is the Eurometropole Lille-Kortrijk-Tournai. In fact, if you look at the website, cross-border mobility is one of their focal points. For the people who don't speak Dutch, a quick translation. So since the development of the Eurometropole, mobility is one of the main focal points. Why? Because the border is not a dead end, but it's an economic, environmental, and societal crossroads in what is a cross-border living area. Second bullet point, because mobility and the freedom of citizens supersedes Europe's boundaries. Clearly, we're only talking about a certain group of people here. Third and fourth bullet points deal with commuting and recreation and tourism. So this is a very comparable example to the one that I had in Germany, Czech Republic. I can keep going on. German-Danish border, selective identity checks when you're in a Flixbus, going to Copenhagen, for example. Swedish-Danish border, the same. Two countries with very friendly neighborly relations, at least an image of being quite progressive societies. Also there, selective security checks at the border within what is still the Schengen zone. What do we learn from all this? First of all, that managing people's border crossings, managing people's ability to be mobile is a very clear geopolitical tool. And I think the example of the Belarusian-Polish border is very clear, where you have a geopolitical dispute between a nation state and a supranational entity that's fought over the head of individuals. This is a second example that I often give. Mobile billboards that were funded by Viktor Orban, so Prime Minister of Hungary, to drive around Brussels, basically to engage in a war of words with Guy Verhofstadt, who's one of the most vocal advocates of the European project. The billboards read, "Hundreds have died in terrorist attacks since 2015, but Verhofstadt says we don't have a migration crisis. This is insane." So what does he do? Of course, he says that migration of migrants and terrorists are the same group of people. And that's the reason why we should make sure that these people do not have access to the European space. What he also says is that the European Union actually has no right to point a finger at Hungary for its very strong and very selective border policy. So again, you see that individuals are being used to create this kind of, or negotiate this tension between the nation state, member of the European Union, and the European Union itself. Now that migration is a geopolitical instrument speaks for itself. I think also tourism is. Right, this Iron Curtain Trail example that I gave at the start of this lecture is basically exactly the opposite. Right there, it's all about making sure that borders do not matter anymore, that we shouldn't make the same mistakes as in the past. But clearly we're doing that. Right, only the image that's presented is being completely different. Now, importantly, and that's one of the messages of my lecture here, is that these are two connected phenomena. Right, you do not have only investment in borders that are being hardened or borders that are being softened, but this occurs at the same time, right, in the exact same borderlands, just with reference to different mobility forms and different people. And why am I saying all this? Because the concept or the domain of geopolitics is still a domain that's very much dominated or assigned to the domain of international politics. It's very much related to large-scale events such as wars, such as referenda, such as Brexit. And of course, these are high-profile geopolitical occurrences, geopolitical instances. But I would argue that geopolitics is very much also an everyday phenomenon, right? That's embedded in seemingly non-political spheres or domains, such as tourism. Right? It can be both repressive, as we've seen between Belarus and the European Union, but also progressive in the sense that it is used to establish friendly neighborly relations, to create or at least an instrument or a development towards cohesive areas, cohesive space. But most importantly, and that's probably the main message of my lecture here today, is that geopolitics is not just about interstate relations. Right? It's also about how we, as a society, which is still very much territorial, right? We still have the European Union, nation states, regions, and so on, in which policy is made. How we, as a territorial society, deal with a world that's increasingly globalizing, where flows of people and money are increasingly transboundary, where these flows of people and money do not follow the exact same territories that we use to make our policies. Right? So it's about this. Managing people's ability to be mobile is about understanding or finding optimal ways of functioning as a territorial society in a world that is increasingly non-territorial, that's increasingly transboundary. So what needs to be done? I think we need to bring the geography to tourism and the tourism to geography. Right? We can only understand how tourism functions as we can only see how tourism is a tool to understand society if we take one step back. Right? We can study tourism impacts for all we like, and it's very important, but we can only properly understand how these tourism impacts are brought about if we understand the underlying processes that structure how we use tourism as an instrument. For that, we need comparative perspectives. We need this meta-level reflection. We need to take this step back and understand tourism as one of the mobility forms that structure our society. And very much we need to focus on the everyday, the low-key, the non-political in this respect. Right? We need to understand, for example, tourism as a tool for geopolitics. And strangely enough, this has hardly been done so far in academia. It's all about tourism, or it's about geopolitics, but it's not about this meta level, this larger overview that I shortly try to reflect on here today. I think this would improve our insights in tourism impacts. Most crucially, it would improve the understanding of our society, our territorial society in a world of flows, a world of transboundary flows. And it would improve our understanding of how borders and border management is a very is a tool in this respect, right, in our changing society. Now, let me end with a slightly idealistic message. At KU Leuven, I try to improve our understanding on all these elements. Right? This is what I do. But hopefully, by creating a better understanding on how our society functions, how our border crossings function, how our border policies function, I don't just contribute to academia, but I contribute to society. And hopefully, by doing so, we raise the awareness just a little bit that we shouldn't have the violent borders in the world, if in the words of Rhys Jones, but that borders can try to become something that unites us, right? That binds us together, rather than that separates us and separates different people. Thank you for your attention.
Thank you very much, Arie. I don't know if there are some questions for Arie right now. You can also wait until the reception, of course, but if not, then thanks again, Arie, and we can move on to the second presentation today of Johan Vellekoop. So Johan also comes from the Netherlands, but from Utrecht University, where he studied biogeology and also obtained a PhD on the environmental change at the Cretaceous Paleogene boundary. And he's working with microfossils to be found in sediment archives to reconstruct environmental changes, climate change in the distant past. So our time scale is changing compared to the lecture of Arie. Now, after obtaining his PhD in Utrecht, he came to Belgium, to Leuven, but he also switched to VUB, and then he came back to Leuven, and he went back to Brussels. So I don't know what you were thinking, Johan, what the best place is. but then luckily, Belspo came up with this FETWIN initiative. And for those of you that were already here last week, they know a bit more about this, but I see some new faces, so I'll explain it again. So FETWIN is an initiative of the Belgian science policy to strengthen the links between the federal scientific institutes and the Belgian universities. And they came up with a program of joint appointments. And so Johan is appointed as a tenure-track assistant professor here at KU Leuven for 50%, but also as a researcher at the Royal Belgian Institute of Natural Sciences. And that is located in Brussels. So again, he's combining Leuven and Brussels. So I still don't know which place you like most, Johan, but maybe you can...
In 10 years, I know for sure.
Okay, good. So he is working on a specific project called MicroPast, micropaleontology of Paleogene marine shelves, correlating the terrestrial domain with the marine shelf environment. That's the whole idea of this project. And you can tell much more about that, Johan. So I'll give you the floor to explain how this cooperation with the museum will look like, please.
Thank you very much. Yeah, welcome, everyone. So the full title of my talk is The Evolution of Climate and Ecosystems in the Cretaceous Paleogene Greenhouse World. So the three key words in the topic, evolution, climate, and ecosystems, will be three different topics I'll be talking about. Let's see if this thing works. Can I? No, that doesn't work. Can I plug that in? Yes, that works. So life on Earth. We have an enormous diversity of animals and plants in the world right now. It's truly amazing. I'm talking thousands and thousands of species of plants and animals. Actually, throughout Earth history, biodiversity has probably never been as high as it has been over the past 1,000 years, or 10,000 years maybe. And all of this diversity is basically the legacy of hundreds of millions of years of evolution. Life has gone through a lot. Periods of great prosperity, evolutionary radiation events, life finding its way, different niches and ecosystems evolving, and periods of adversity, where things didn't go as well as it did. And eventually you see extinctions, and some of these extinctions occur quite rapidly, and together form sometimes events called mass extinction events, when enough groups of plants and animals go extinct so that ecosystems start falling apart, leading to these mass extinctions. This is a graph of the last let's say 550 million years till present. And with these time bins in percentage of extinction of, in this case, marine genera. And you see all these little spikes, and there's basically a background curve, and some of the spikes, short time intervals where a lot of species go extinct. We know these big 5 ones, Ordovician, Silurian, the late Devonian, the Permian Triassic, Triassic Jurassic, and the Cretaceous Paleogene boundary. So different moments in time where things start falling apart. I guess the most well-known is this one, right? The last one where you have an asteroid impact that killed the dinosaurs. Or, well, over the past there have been some different talks about potential other causes. Maybe it was the dinosaurs just missing the Ark of Noah. And this is relevant for us because we are facing an extinction event at present too. This graph, the last 500 years, different groups, fish, reptiles, birds, mammals, amphibians. And you see all of them are having quite large percentages going extinct. And if you extrapolate this, within a few hundred years, we'll be looking at similar extinction levels as, let's say, an asteroid impact. And that's a lot of different causes of this biodiversity loss. There's a couple of them presented here. Changes in land sea use, species over-exploitation, fishing, etc. And this quite relevant aspect, climate change as well. So the first part of my talk will be mostly on biodiversity changes, and I will later on focus some on the second part, on the climate change. So this problem raises a few relevant questions such as which groups of animals and plants are actually most vulnerable to change? What are the long-term consequences for ecosystems on Earth if you start taking away different species? And eventually, on the really long term, how do ecosystems recover from this stress? It's difficult to answer these kind of questions with, for example, people try it with mesocosm studies, basically putting an aquarium, adding some animals in there and see what happens if you take out. But in ecosystems, everything is connected. Everything is connected. It makes it really hard to say what are the consequences if you take out one of these puzzle pieces. And one of the ways we try to solve that is with this key saying, the past is the key to the future. We can learn from past events where extinctions occurred. And of these events, one of the things that's striking, what's different between the past extinction events and modern day extinction events is that these extinctions occur at an unprecedented rate. Well, as I said earlier, there's only one extinction event that happening on the same space. Actually, as humanity, we are causing extinctions at the same rate as an asteroid impact. That is something not realized. So that is one of the reasons why a large part of my career I've been working on this Cretaceous-Paleogene boundary mass extinction. So the Cretaceous-Paleogene boundary, 66 million years ago, most well known for the extinction of the non-avian dinosaurs, what we know as the dinosaurs. But actually a lot of other animals went extinct as well. The marine reptiles, these mosasaurs, etc., the equivalent of the dinosaurs, but then in the sea. Famous groups such as the ammonites and belemnites, squid-like creatures. And this is actually probably the most important in this list, about 75% of all plankton species. Plankton is the basis of the marine food chain, the base of the ecosystem. And if that disappears, the ecosystem collapses. And as we all know, this is caused by the impact of a large asteroid. That makes it one of a rather unique geological boundary. It's one of the few, I guess the only geological boundary that everywhere you go around the world, you can recognize it in the rock record. There's not a single place around where the Cretaceous-Paleogene boundary is not marked by a sharp transition. And you can put a knife in there. This is where the dinosaurs lived, and this is where they were extinct. A rapid event, which makes it very interesting and very difficult to study because lots of these changes occur actually on a time scale that is very difficult to reconstruct for an event that is 66 million years ago. As with all other mass extinction events, it's never one catastrophe. It's always a series of catastrophes occurring together or in sequence. There's all these different timescales playing here. Within the first day, impact blast, tsunamis, misery, weeks to decades, acid rain, and impact winter caused by the dust blown into the atmosphere, blocking incoming solar radiation, followed by climate change in the thousands of years following the impact. And it takes millions of years for life to start recovering and the global carbon cycle recovering. This is actually one of the things that makes this such an interesting event, all the different timescales at play. I had the pleasure to work on a IODP core that was drilled in 2016 within the Chicxulub impact crater. It's a very international project. One of those drill rigs. I was not allowed on the rig myself, it's a pity, but drilling into the crater, basically recovering the fin fill of the crater, and wonderful stories come out of there. This is a record of charcoal and other combustion-related products, indicators of high temperature combustion. So it comes up with a story like this: the day the world burned. It's a bit of drama. I like a bit of drama. I guess that's also why I like this kind of, it's with the poor dinosaurs laying there. Other events happening at the same speed, at the same event, we're talking about, for example, this tsunami that occurred caused by the impact. This is a model run. It's actually already generated in 2017-18. I've seen it at the presentation in AGU. It's never been published, unfortunately. You see, most of this is a scale in hundreds of meters. So most of the world saw changes of 5-10 waves of 5-10 meters. And it's only here in around the Gulf of Mexico, you see all these, waves with an amplitude of hundreds of meters. Unfathomable. You can't really imagine what a tsunami wave of 100 meters looks like. Been involved in a study. One of the tsunami deposits really far into the western interior seaway up north in the United States, North Dakota, which is all these classical seismological features characteristic of tsunamis. And there's lots of interesting fossils in there. Well, first of all, also this glass tektites. So little pieces of molten rock have been blown into the atmosphere, landing down. It's all there in these tsunami deposits. This effectively ties this tsunami deposit clearly to the asteroid impact. And there's all these fossils in there. We find fossil tree logs, shark teeth, ammonite shells, so it's both marine and terrestrial stuff, and loads of fossil fish. Beautifully preserved, you can see all the scales, etc. You can clearly see them all aligned, so it's clearly with the flow of the tsunami being deposited there. And what's interesting here was that these fossil fish have these little spherules, so that those are those impact tektites, the pieces of molten rock, locked in their gills, which shows that they were probably alive and swimming through the water when these tektites were raining down. I think this is the first real evidence we have of an animal going extinct by the impact. Going extinct, dying by the impact, not just going extinct, but actually dying on the day of the impact. It's quite a spectacular story. Well, after that, of course, at some point the waves die down. Is the misery over? No, because then really the most troublesome part starts with all the dust, soot, sulfate, aerosols, stuff being blown into the atmosphere. This is a core that's been drilled just outside of the Selective impact crater, and you find a lot of gypsum in there. Gypsum, this is a chemical formula, has sulfur. When you start burning sulfur, that's a lot of sulfur. That's a problem. That's a big-ass problem for planet Earth. And combined, this sulfur and the soot and the dust stayed in the atmosphere for years, probably, cooling the Earth's surface. And this was one of the goals of my PhD, to find proxy-based evidence for this cooling. In the end, I found it with this temperature proxy based on the membrane lipids of archaea, so unicellular organisms that live in the seawater, that adjust the chemical composition of their cell wall to the temperature of the water. And even though the cell itself disappears when it dies, these membrane lipids are preserved. And based on that, we can reconstruct temperature. And I have a couple of sites where this is the black line here, horizontal black line here. That's the moment of the impact. Above that, we find that these dark blue things are elevated levels of iridium. This is impact dust raining down, and exactly the same level we see this cooling. In 5, 6, 7, maybe 10 degrees down of the average of the seawater. So this is again one of those nice dramatic storylines. The poor little dinosaur shivering in the cold, and eventually, I really like the drama of this image with the carcass of the dinosaur and the mammals, our ancestors, fighting over the corpses. I like that image. But there were, of course, just like mammals, there were survivors. It's actually amazing, with all of this drama, all of this misery, that still a lot of animals survived all of this. All of them probably were generalists. They could find different food sources, had a form of dormancy, could survive periods without food, without light, cooler temperatures. One of my pet groups is the dinoflagellates, a group of unicellular plankton. And in their life cycle, which is depicted here, at some point they make this resting cyst, a little cocoon in which they can sit and sink to the seafloor and then wait there. They have a little sensor, so one feel if the temperature is already okay, if the light is back, and if not, they can wait. People have been doing experiments with these, and actually, they still live today, these dinoflagellates, and you can keep them in a fridge in their little cyst for dozens of years. And there's experiments that's still going on, and you put these encysted dinoflagellates, and even after 20, 30 years, you can still take them out of the fridge, put them back in a warm medium, put a light on it, and plop, they come out again. That's what you see happening here. So this is this dinoflagellate in its cocoon. At some point, it opens a little hole, and the living cell leaves its resting system. This cyst stays on the seafloor. Those are actually the fossils that I'm studying. Look like this, an example, and you see clearly here this rectangular hole in its little cocoon in which it left its cell. There's different ways of looking at what the biotic responses were of all these dramatic events. I've been studying the effects in this region, for example, in the Belgian-Netherlands border region near Maastricht and Liège, where you have these deposits of a shallow carbonate platform, very rich in fossils. So particularly this quarry, it was in this picture is from 2007. The quarrying ended in 2008. And what's really interesting is here you have both layers. This interval is deposited the last thousands of years, so before the impact. And just above you have an interval that represents the first thousands of years after the impact, maybe even the first hundreds of years after the impact. And all of these deposits are completely full of fossils. Particularly lots of these fossil gastropods, so sea snails. All these beautiful colors and preservations, a really rich fauna. And if you look which species occur where, again here this horizontal line is the extinction level. And you see that about half of all species go extinct and half survive, they go on. Eventually, over a larger time interval, they are replaced. But first, there's quite a lot of survivors. 50% of the organisms here survive. And if you look at which groups were dominant, before the impact, this gastropod was dominant, it's pelican foot. And after the impact, this species is dominant. It's a different type of pelican foot. So what we see here is not that an ecosystem that is completely overthrown, but rather one species is replaced by a very similar other species. So what we learned from that is actually in this particular region, the ecological effects were not as severe. And we think that has to do with the background conditions. Some ecosystems are more adjusted to the conditions such as food deprivation, which occur during the impact. So the conditions and the type of ecosystem before the impact has lots of effects, has a very important driver in the consequences of the impact. And I think this is also a key message for the modern day crisis, that it really depends on what the functioning and how your ecosystem functions, how it will respond to changes. And after all of this, well, life recovers, thrives. I think it's important to realize that every single plant and animal that lives today is a descendant of someone that survived these catastrophes. In fact, you're all the descendants of survivors. Little piece about this other part, climate change, and this is also a main focus of what I'll be doing over the next few years here. We all know climate change is real. It's happening now and it's affecting human lives. This is a graph with temperatures, yearly temperatures compared to the average for the 20th century. And you see just there's no mistake there. It goes up and up and up. And if we zoom out a bit even further, this is the last 2,000 years. And you see, well, it's basically almost a straight line, dipping little and snap. This is our activity over the last few hundreds of years has been dramatically changing our planet. Even 30 years ago, the Earth was still 0.5 degrees cooler than now. The question is, of course, what will the future bring? Where are we heading? There's this target we have of the Paris Agreement targets of 1.5 to 2 degrees warming. Well, will we make that? If we're really lucky. I mean, this is these different scenarios. If you have the very low emission scenarios, then maybe, but as we are going right now, and there's the, let's say, middle ground scenarios and the higher scenarios seem more likely. And then we're looking at not 1.5, not 2, but 3 or 4 degrees warming over the next 100, 200 years. That gets quite dramatic consequences. And again, it raises some interesting questions. What will that future climate look like? What are we heading to? Not only in terms of the average temperature, but what will the intra-annual weather variability be? Will we have more extreme weather events like the flooding we had this summer? What will the summer temperature be? What will the winter temperature be? All things that are relevant to us as humanity. And then going back to these ecosystems, how are ecosystems affected by this? Especially because it's such a rapid change again. And again, there, coming back to this, the past is the key to the future. We can look back in time because the future climate that we are heading to is not unique. We've had similar CO2 concentrations in the past. This is the different scenarios, the most positive scenario, middle ground scenario, and the worst case scenario. Plotted here, the CO2 variation over the last 100 million years still present. And you see that even for the middle ground scenario, we have to go back 30, 40 million years to reach same levels. And the temperature over those years has been slowly dropping. So there's a few time intervals in the history of Earth where we had similar climate. In particular, the last moment we had such a warm climate, warm CO2 was this interval, the Eocene. And before that also the late Cretaceous with even higher temperatures, which makes these two time intervals that I'm working on, the Cretaceous and the Paleogene, very interesting. You can see them as worst case scenario climates. A little bit of details about these two past greenhouse. We call them greenhouse worlds. And this is a world where temperatures are so high that there's basically no ice on the poles. Early Paleogene, and in particular the interval between 56 and 48 million years ago, atmospheric CO2 between 1,000 and 4,000 parts per million. Average global temperatures, 5, maybe up to 10 degrees warmer than today. And the late Cretaceous, between 100 and 66 million years ago, which also very high CO2 concentrations and temperatures 3 to 10 degrees higher than today. This is an alien world to us, a world that looked entirely different. 55 million years ago, Belgium looked like this. This is tropical rainforest. Actually, for the people who've been paying attention, these trees are taxodiums. This is the big blocks that we have at the Geo Institute in the hallway. Fossil trees like this. We have these little prehistoric horses. Back then, horses were this small, very cute. But this is what Belgium would look like did look like in such a warm world. I mean, we have high atmospheric CO2 concentrations, high global temperature, and of course, high sea level. The positions of the continents was more or less the same as nowadays, but just no ice on Antarctica. Large parts of the global continents flooded. Also here. And what's interesting, this time interval, you have this large-scale global warming over hundreds of thousands, millions of years. But on top of that, there's even shorter time events, so-called hyperthermals, very short-lived moments with very rapid climate change. They are actually, this is a difficult graph, but you see all these little spikes and all the gray bars. There's these hyperthermals, rapid warming events, occurred numerous times over this time interval. Some bigger, 4 degrees, 5 degrees warming, some smaller, with just 1, 2 degrees. And you see the top graph, this is the carbon isotope curve, and you see all these spikes up, temperatures have to go up, are mirrored by a change in the carbon isotopes. It means that this is a response of the global carbon cycle. suggesting that these warming events are probably caused by a rapid injection of isotopically light carbon into the ocean or atmosphere, like we are doing today. So you can see this, these are really the closest thing we have in terms of an analog to current global climate change. Again, current global climate change is happening at an extremely rapid pace. And these are few examples that we have in geological history where climate change is occurring, I would not say at the same pace, but at least fast. And there's a lot of them. There's a deep sea core, and well, at some point, they're all over the place. So what we're saying is that these are rapid events caused by rapid ejections, and the nearest analog we have to current global climate warming from the geological record. And what is interesting, that this same period with all these rapid warming events is actually a period of tremendous evolution. It happens to be, this is in case for mammals. This is a graph from 200 million years ago to 66 million years ago and after, and this is the asteroid impact. And that starts off and radiation, and after that there's an enormous radiation among mammals, including this cute creature. Say hello to your mother, father, I cannot see. But this is mammals, as specifically hominids or primates, I must say, evolved also in the same period, and lots of other groups, amphibians, birds, and even whales evolved. And what is interesting is that we have a lot of geological, a lot of outcrops actually, or subsurface material throughout Western Europe, so Netherlands, Belgium, France, UK, of this time interval. And that's actually one of the things I will be focusing on for the next few years, is to see what's happening in ecosystems across these different events, working with my favorite little tiny flagellates, but also in collaboration with the Arbins, the National History Museum in Brussels, on, for example, this is a little fragment of a jaw from a mammal from one of those layers. So studying both the flora, plants, algae in the ocean and on land, and what happens with those mammals. One of the things I want to answer is, how is the sensitivity, how do these ecosystems respond to climate change? What is the sensitivity? At which level of climate change do you see a turnover in ecosystems? And is this different between different groups? Or does the ecosystem respond the same for the same temperature change? And I try to use both the top-down perspective, looking at these large mammals and other, well, this in cases marine realm, vertebrates as ecosystem indicators, the most vulnerable groups probably in an ecosystem, and the bottom up, the primary producers, the drivers of the ecosystem. I'm myself mostly specialized in these phytoplankton, but we have a couple of groups. We're working towards the top part as well, amongst others. My new PhD student, Sophie, we're working on fossil crocodiles and evolution of fossil crocodiles in this interval. Another key element I'd like to work on is what the interannual climate or weather variability is in this greenhouse world. Because again, it's not the average temperature change that is a problem to us, right? I mean, 0.5 degrees more, it's the events such as those flooding events we had this summer that is the most troublesome for us. And one of the ways to assess these weather patterns is using fossil mollusks like this fossil gastropod, a sea snail. This fossil is actually one of my prized pieces from my own collection. What was nice is these shells, they build their shell in the seawater layer for layer for layer for layer, incorporating information of their environment during their life. Basically, just as a tree, these gastropods have growth rings, and you can reconstruct the changes in, for example, seawater temperature during their life, and lows during winters and highs during summer. And potentially, if you go high resolution enough, you even see changes within those seasons. We have had a student last year who saw these, what they think at the moment are weather patterns, changes in weather patterns within the summers based on these gastropods. So those are basically the three main targets I'll be working on. On one hand, the interannual variability, then the more large-scale ecosystem changes that we see, and to both the climate change and in general to biodiversity changes, extinction events, and what we can learn from that for the future. And on that, I would like to thank you for your attention.
Okay, thank you very much, Johan, for this very nice introductory lecture to your work here. Are there some questions for Johan? Seems to be that everyone is thirsty.
We have a question.
There is one here, Nicole, please. I will wait, Nicole.
Yeah, thanks, Johan. Great talk. So I have a question about the speed of the change. So can you tell a little bit more about those events in the past? Because you said they might be a bit slower, but maybe you can elaborate a little bit on that.
Yeah, well, they're pretty certain. We are certain that they are slower. How much slower is difficult. The problem with events that happened 50 million years ago is always that it becomes difficult to constrain their rate of change to a very high detail, but we all assume that they are slower than modern day change. The onset of these events must be over, more likely to be in the order of thousands of years rather than hundreds of years. But again, it's difficult. I mean, has been some discussions on this. I would lean more towards 1,000 years than to 100 years. But again, it's difficult to pinpoint this exactly. Yes, does that answer your question?
Yes.
Good.
I agree with you that we can.
It's slower, but it is for everything we have in the geological record. It's the fastest. Well, the changes caused by the asteroid impact were faster in terms of also climate change, but there's so much happening at the same time that it becomes really difficult to get the climate component out. So that's why I say the hyperthermals would be better.
Okay, thank you. Other questions? If not, then I would like to invite you all to the reception which takes place downstairs. And that's a good opportunity to to raise more questions to both Arie and Johan.